Hello everyone, welcome to Kappa Math. Today we're going to be talking about how to expand a logarithmic expression. In order to do that, we need to get a basic understanding of the properties of logarithms. Let's take a look at those. All three properties assume that a is greater than 0 and b is also greater than 0, since we cannot have 0 in the argument of a logarithm. And as we'll see in the second property here, we cannot have a denominator that equals 0. In the first property, if you have the natural log of a product, to expand that, you have to take the sum of the natural log of each factor. So if you have the natural log of AB, that is equal to the natural log of A plus the natural log of B. The second property states that if you have a quotient in the argument, then you take the difference of the numerator and the denominator. So if you have the natural log of A over B, then that could be expanded to the natural log of A minus the natural log of B. The third property states that if you have a constant as a base raised to an exponent, you can expand that by extracting the exponent and make it a product of the natural log of the constant. Okay, and for all three of these properties, they all hold true for any base. So natural log always has a base of e because that's the definition of a natural log. But you can also have log base 7 or log base 10. Okay, it doesn't matter. All these hold true for any base. Okay, so let's take a look at some examples of how to expand some of these problems. So the first one is pretty straightforward. We can use the second property of logarithms. So we have natural log of x over 4. That can be expanded to the natural log of x minus the natural log of 4. Okay, so since we had a quotient, we can take the difference of the numerator and the denominator. So that was pretty straightforward. Let's take a look at this next one. So notice you have a product in the numerator over just a constant. So now you can take, the thing to remember about these is you always want to do the division part first. So you take the difference. Okay, so we have natural log of xy over z. So we could have natural log of xy minus the natural log of z. Okay, so we still have a product here, so we can further expand this into the natural log of x plus the natural log of y minus our natural log of z. And that is our final answer. Okay, so this next one, number 3, is a bit more complicated. So let's see if we can tackle this one. So notice first off that we have a product right here. X times this guy over here. So we can first take the sum of the natural log of the factors. So we have natural log of x plus the natural log of the square root of x squared plus 5. Okay, so now we can use the third property of logarithms right here. Okay, so we don't have an exponent, but we can rewrite this for it to have an exponent, okay? So we can have the natural log of x plus the natural log of, we're going to make this square root as a power of 1/2 because those are equal. So we have x squared plus 5 raised to the 1/2 power. Okay, these are equal right here. They're just rewritten in different ways. So now we can go ahead and use the third property of logarithms and extract this exponent, put it out front right there. So let's do that. Natural log of x plus 1/2 times the natural log of x squared plus 5. And we're done, okay? Now for the final answer right here, always make sure to put this in parentheses, put this quantity in parentheses. If you don't, then we are assuming we are only taking the natural log of x squared, not the plus 5 along with it. So always make sure you put these parentheses out here. All right. So let's take a look at one last one. And we have, number 4, we have the natural log of the product 3e squared. Okay. Now, it is tempting to use the third property of logarithms right off the bat and extract this 2 and put it out front. That would be incorrect. Only the e is being squared. The 3 is not being squared. If the 2 were out top here, then we could do that. But only the e is being squared. So right now we only have a product, and we can rewrite this as the natural log of 3 plus the natural log of e squared. All right. Now we can go ahead and use the third property of logarithms to extract the 2 and put it out front. So we have the natural log of 3 plus 2 times the natural log of e. Okay, but we're not quite done yet. Sure, it's expanded, but it is not simplified. What is the natural log of e equal to? Well, natural logs always have a base of e. Okay, so pretend there's an imaginary e right there. E raised to the 1 to the what power is equal to e? Well, that's just 1. Okay, so the natural log of e always simplifies to 1. So we have the natural log of 3 plus 2 times 1. And of course, that could be simplified to 2 plus the natural log of 3. And that right there is our final answer.